So this is video number 2 on the limiting reactant. So hopefully that delicious first video gave you a concept of what we're going to do and why we're going to do the things on the part moving forward here. So you can see we're moving into our next section, and this is limiting reactant. And you're also going to learn something called percent yield. So let's get a nice full view of this and just jump in and start doing this. I think the introduction was covered by the cheeseburger chemistry. You're going to run out of something, and you have an excess. So we ran out of hamburger patties, and that was the limiting reactant. And the excess, we have a whole bunch of buns left over, and we have a bunch of cheese left over as well. So those are in excess, and that's almost always the case with these reactions. So here's the thing. Up to this point, we've just had the one number. You throw the number down and you start crunching. Well, this one we have two numbers, but what you're going to do is you're going to do two mass problems. Okay? So we'll start with glucose. 28 grams of glucose. Next one we'll start with oxygen, and then we'll assess where we're at with that. Okay? So what mass of carbon dioxide is produced? Well, hopefully you guys remember from biology this classic equation: glucose plus water gives you carbon dioxide and water. And of course, this is also cheeseburger chemistry, because here you're eating your cheeseburger and you're getting a bunch of energy over here from that. Okay, so that is our balanced chemical equation, of which we will use the coefficients. So let's start with 28 grams of glucose first. All right, and again, I'm going to go through these fairly quickly, so hit that pause and get good notes. So you got 28 grams, and yeah, you got to put down grams of what? So you do need to put that C6H12O6. And for the purposes of this lecture, let's just assume that you're comfortable doing formula units and continue to practice it, obviously, but let's just trust them for right now. And all you're doing is you're adding up the atomic weight, and that's grams to moles. And then you do your mole to mole conversion. This is what we have. And remember, just take what's on top there and write it down on the bottom there. And this is what we're looking for. In both cases, we want to know how much CO2 we have theoretically. So then you've got this many grams per 1 mole. Watching 2 sig figs, 1 2 digits. Your answer can have 1 2 digits. So in theory, given that much 28 grams of glucose and excess oxygen, then you could get 41 grams of carbon dioxide. But we didn't have an unlimited amount of oxygen. We had a given amount of oxygen, and that was 14 grams. Okay? So you're going to just do the same thing, grams to moles, and now you get to do the mole to mole conversion. And remember, even if they're both the same number, write them both down. So there's 6 moles of oxygen for 6 moles of CO2. Now the last step is going to be the same on both of these problems, right? 44.01 grams of CO2. And in theory, you could get 19 grams if you started 19 grams of carbon dioxide if you started with 14 grams of oxygen. So remember, this one was 41 grams. So just like the cheeseburger problem, the right answer is 19. All right? So that's your step 3. I think it's a good idea to write this stuff down. You can use your notes on the test, so when you get to a limiting reactant problem, you can remind yourself, hey, I compare the two masses. The smaller one is the limiting reactant. Thus, oxygen was the limiting reactant. You're going to run out of oxygen. You had plenty of sandwiches left, but you didn't have the oxygen to burn them. So 19 grams of CO2 is produced. So not only, do you recognize the smaller one, but that is the actual answer in this problem. Okay? Now, percent yield. Excuse me. So, if 15 grams of CO2 were produced in the previous problem, what is the percent yield? So, you take the actual yield over the theoretical yield. Now, theoretical, that is crunching your numbers, taking your calculator out, and figuring out what are the different things that you have when you're doing this. Okay, so you take that number and you just start crunching those numbers. Okay, so the actual yield turned out to be 15. So you just put 15 over 19. Stay in the good habits. 15 grams of CO2, 19 grams of CO2 times 100. That's a 79% yield. So you should have gotten 19, but no experiment is perfect. So you don't always end up getting what you think you're going to get. So again, actual is what you got in the lab. Now we're doing a lab on this, so we're going to be able to do a percent yield. Actual is what we got. We're going to do some theory, crunch the numbers on that, and then we will be able to figure out the percent yield. Sometimes 10% yield is all you'll get. Sometimes you can get more. You get some impurities in there, and you get 110% yield. How did that happen? Well, some impurities came into the system. So percent yield almost always coupled with a limiting reactant problem. Okay, so here's another one that we can do. So take some time to get that all written, and you've got 155 grams of N2H4 and 175 grams of N2O4, which is also both liquids. Okay, so you're going to make nitrogen gas, but the product they're interested in this case is how much water are we going to make when we're doing these reactions. So that's the question that we ask instead of asking how much nitrogen. So in both cases, we'll do mass to mass, starting with that number, going to the mass of water. So let's start with N2H4. Boom, you have that. And again, let's just talk about the concepts. You know that you're just looking up the atomic weights, and you have that new stoichiometry handout, so it's going to be 2 places to the right. And again, if your answers vary, there's no guarantee that all those numbers are the same as what this lecture slide has. So be cool if it's off by a little bit. Just write down what you get when you use your periodic table and get that. So there you've got it in moles. That's the goal. The goal is the mole. Then you can do your mole-to-mole conversion. This is what was given to you. Remember, we're looking for water 2 to 4. Don't reduce that. Leave it as a 2 and a 4 to show the coefficients in the balanced chemical equation. And then on the other end, water, we can convert a mole of water into grams. So in theory, 174 grams of water. All right? Now we start with the second reactant. Boom. 92.02 grams per mole. Just look up those atomic weights. Now the ratio here is 1 to 4. So 1 is our known. This is our unknown we're trying to find. The last step is the same as it was in the previous one. And you've gone grams to moles, mole to mole, grams to moles. But you did it 2 times. And in one case, you got 174 grams, and in the other case, you got 137 grams, both of the same product, water. Only one of those can be right, and just like the cheeseburger, the one that is the least, the 5 cheeseburgers, is the right answer. Just like this one, 137 is going to be our correct answer because it's the smallest number. All right, so N2O4 is the limiting reactant between the two of them, and 137 grams of water is produced. So, just like we did in the other one, let's finish up with a percent yield. Let's say someone did this experiment and they got 129 grams in the lab. Write the equation up. You've got to have the formula to tell the story of what you're doing. Percent yield, actual yield over theoretical yield times 100. So when you're doing percent yield, I expect to see this whole equation on the test, and you can check for that on your worksheets as well. So that's 129, which is what we actually got, and in theory should have gotten 137. We're pretty close. Notice this is 3 sig figs. 1, 2, 3, 1, 2, 3, 1, 2, 3. So 94.2% yield. And that's all you have to have for the unit is just percent. You don't have to write percent yield again at the end. Just the percent is okay for the units of measure. Okay? So we've got a nice set of problems. What I'm going to do is I'm going to post the problem with the answer right underneath it. So have the discipline not to peek too much and look at the answers. See if you can do them on your own. You really want to make sure that you're comfortable doing those without using the answer key right away. I'll post 2 separate documents. One will be, here's the percent yield problems, here's the percent yield solutions. And so you can correct your own on this one. And I'm just going to trust that you are wise enough in the ways of academics to get good at doing these so that when you get the one on the test, you'll do well. And you want to start catching some of those little mistakes as we move forward. Okay? So this is a very important concept, percent yield, as it was coupled with limiting reactants and cheeseburgers and chemistry.